observers on Earth. Have I started the recording? Anybody can confirm?
No, sir, not yet.
No, sir.
Not started, sir.
ये बोलना है ना?
Recording in progress.
हाँ. But due to a phenomenon called liberation, observers on Earth can see a little bit more of the moon. Liberation is of two types. Liberation is of two types. One liberation in latitude, two liberation in longitude. These are the two types of liberation which we will talk about. Liberation मतलब freedom होना. अभी तुम लोगों को liberation कब मिलेगा? What do you think? When do you think you will get liberation?
After clearing second match, sir.
After getting COC, sir.
No.
मास्टर बनने के बाद
No, wrong. After getting COC and getting a bloody job, man. तुम लोग COC लेके बैठा रहेगा. नौकरी नहीं तो क्या फायदा हुआ इसमें? Liberation. वो मास्टर के बाद भी वैसे liberation, you will never be liberated. So don't worry.
So one step at a time, sir.
हाँ, तो लाइफ में कभी लिबरेशन नहीं मिलेगा, बट सीओसी लेके नौकरी मिलके जहाज में जाओगे, अपना यूनिफॉर्म पहनोगे, तब वन स्टेप लिबरेशन हो गया. चलो ठीक है, एटलीस्ट मंथ एंड में सैलरी मिलेगा. दैट इज द मोस्ट इंपॉर्टेंट थिंग राइट नाउ फॉर यू. राइट और रॉन्ग? So
Right,
this
sir.
what is liberation? Correct. Now let us see what is liberation in latitude.
सर सुनाई नहीं दे रहा है.
काहे? मेरे को तो सुनाई दे रहा है.
हाँ सर, अभी आया है सर आवाज.
अब मैं बात नहीं किया इसलिए सुनाई नहीं दिया ना. अब मैं बात
नहीं
कर
सर,
रहा हूँ.
बीच में कुछ बोल रहे थे ना, तो बीच में कट हो गए थे सर आवाज.
बाकी किसी को ऐसा है कि बीच में कट गया?
No, sir.
तो बेटा तुम्हारे एक बार देख लो अपना नेटवर्क एक बार देख लो, ठीक है ना. माय नेटवर्क इज फ्रॉम द रिचेस्ट मैन इन द वर्ल्ड, जियो फाइबर. सो वो खराब नहीं हो सकता है. ठीक है ना. तो जियो फाइबर है सबसे बढ़िया अभी.
सर प्रफुल्ल का ही खराब है सर.
हाँ,
इसी का खराब है सर.
समझा नहीं क्या बोल रहे हो?
प्रफुल्ल का नेटवर्क खराब है सर.
क्या जियो फाइबर का?
प्रफुल्ल का सर.
सर बोल रहे प्रफुल्ल का खराब है सर.
हाँ वही है. बिकॉज now Jio Fiber, because I had Airtel earlier. Now because Airtel, I could never take class properly. Then I changed over.
मेरा एयरटेल है सर अभी, इसके लिए सर.
हाँ, एयरटेल मैंने कंप्लेन करके मैं परेशान होकर फाइनली चेंज कर दिया. एंड फॉर सेम प्राइस आई गॉट जियो फाइबर व्हिच इज मच बेटर. लिबरेशन इन दैट. कौन सा? हाथवे. अच्छा. बट यहाँ
रेल वायर भी अच्छे चलते सर. रेल वायर
अब वैसे तो बहुत है. नाउ आई एम ड्राइंग द अर्थ and I am drawing the moon and showing you what liberation. Then after I will give the notes. ये moon है. It is not to scale, mind you. ये moon है. The axis of the moon is tilted. Therefore, observers on Earth can see. अभी observer क्या दिखता है? Observer तो ये दिखेगा ना, यहाँ तक दिखेगा. So observer on Earth, when axis tilted towards Earth, you can see more of the moon's northern polar region. And when it is tilted like this, observers can see more of the moon's southern polar region. Because of this, finally, observers on Earth can see more of moon's northern and southern polar region. So it means that the moon's axis is tilted to the vertical at an angle of 6.5 degrees. when the axis is tilted towards the earth, observers towards the earth, observers on earth can see a bit more of the moon's northern polar region. So you can see a bit more of moon northern polar, as explained in the figure. When the axis is tilted away from the earth, observers can see a bit more of the moon's southern polar region. Due to the combination of the above, observers can see more of the polar regions. This is known as liberation in latitude due to which observers can see more of 6.5% more of the moon's surface area. This is what it is. So due to liberation in latitude, you can see 6.5% more than the normal. 50% दिखता था, अभी 6.5% more दिखेगा because of liberation in latitude. कोई doubt है तो पूछो.
सर ये जो मून tilted है with respect to अर्थ है क्या? अर्थ एक्सिस?
No. Always tilted to the plane of its orbit. No. The reference of any planet, anything is the plane of its orbit. So when we say vertical, we actually mean vertical of the plane of its orbit. If you want, you can write that. Vertical to the plane of its orbit. The plane of the orbit is by default the reference for any, because it's space. No, space में कोई direction नहीं है ना. So tilted to what?
Yes, sir.
Tilted to what? The only reference is the plane of its orbit. जो ऑर्बिट जैसे अर्थ का राउंड जा रहा है, उस ऑर्बिट का 6.5% tilted. That is the same way.
But sir, we can say that the Earth जो भी tilted है, उसके tiltation के respect में 6.5 डिग्री ज्यादा है.
नहीं, उसका tilt के respect नहीं है. The plane of its orbit. That is all. Nothing to do with Earth. You cannot compare apple with oranges. Earth's tilt is something else. Moon's tilt is something else. So it is tilted to the plane of its
Okay,
orbit around the Earth. ठीक है ना? Earth is tilted to Earth axis tilted 23 degree 26.7 minutes to the plane of its orbit around the sun. वो अलग है. Those are two different benchmarks. ठीक है ना? Now we come to liberation in longitude. Now we are talking about liberation in longitude. The moon revolves around the earth the moon rotates on its axis. At a once during a sidereal period of 27.33 days. Thus, its rotational speed is constant. The moon's orbital velocity, however, is varying. How is it varying? And why is it varying? Anybody? Orbital velocity? Bolo.
Sir, Kepler second law.
Correct. As explained by Kepler's second law. Sometimes faster and sometimes slower. At apogee. Apogee matlab? When moon
Farthest point.
is, yes, farther away from the earth, the orbital velocity is less than, so it is slower that time, no? When further away, less than the rotational speed. इसको मिटा दो, ये डायग्राम तो चाहिए. ओके, इसको मिटा दो. Is less than the rotational speed, and thus observers on Earth can see more of the moon's eastern fringes. That eastern, how do you remember? Apogee, eastern, both are vowels. How to remember? A, east. That's how you read. Just for you as a thumb rule. Apogee means eastern fringes. Don't try to logic it. Yes, I have, because when the speed of revolution is less, you see more of the rotation is faster, so you see more of the eastern fringes of the moon. Fringes means eastern side. At perigee, when the orbital velocity, you always talk about orbital velocity being faster or slower, because rotational speed is always constant. Orbital velocity is more than, because you're going faster now, because you're closer, more than the rotational speed. Observers on Earth can see more of the moon's western fringes.
सर ये फ्रिंजेस का क्या मतलब
Fringe मतलब edges, side में, longitude, no? Fringes means this is liberation longitude, no? So side का, from pole to pole. That side.
ओके
Due to a combination of these, observers on Earth can see more of the, no, this is known as, this is known as liberation in longitude. Due to a combination of liberation in latitude and longitude, observers on Earth can see almost 59% of the, actually suppose only 50% because same phase it is showing, no, of the moon's surface area. The balance 41% can never be seen from the Earth. So if you want to see the balance 41%, where you should go? कहाँ जाना है?
सर
हाँ बोलो.
स्पेस में सर.
हाँ स्पेस में अभी राइट नाउ द कॉस्ट इज $1 बिलियन. तो अगर $1 बिलियन तुम्हारे पास स्पेयर है, then you can go on the space and you take me along also. Both of us can go and see the other space of the moon. ठीक है ना?
सर $1 बिलियन स्पेयर में.
$1 बिलियन स्पेस में जाने की थी. हाँ स्पेयर में
वो
अगर
होते तो इधर आना था
मर्चेंट नेवी में नहीं होता.
सर, वो होते तो इधर आना था क्या?
यही से देख क्वेश्चन है.
नहीं अगर है who knows, अचानक से अरे मेरे पॉकेट में $1 बिलियन है, चलो मेनन सर को लेके हम लोग एक बार स्पेस में घूम के आते हैं. सर वो तो पॉसिबल ना?
सर प्रफुल रॉकेट बना रहा है सर, उसमें जाएंगे हम.
हाँ जरूर जरूर, मेरे लिए एक सीट बुक कर दो, को पायलट.
Sir, he is not a good engineer.
Who wants engineers यार? हम लोग नॉटिकल है, हम लोग चला लेंगे ना, क्या है.
सर एग्जाम में लिख देंगे, मेनन सर बोल रहे हैं इसके लिए 59% दिखेगा.
Anyway, this is called liberation in longitude and liberation in latitude. Now we come to the next. I thought of taking extra class today, लेकिन हम लोग का 5 बजे प्रिंसिपल ने मीटिंग बुलाया है. क्या बोलेगा? Every time I think of taking extra class, something else turns up. अभी इंस्टीट्यूट अभी लॉकडाउन हो रहा है ना पार्शियल, उसके लिए.
थैंक यू सर.
हाँ आज से चालू है. हाँ तो मेरे
वापस दे दो सर एक बार.
एक डिस्कोर्स चल रहा था, तो अभी वो बोलता है कि अभी फिलहाल ऑनलाइन 3 दिन ऑनलाइन करो, फिर देंगे क्या करना है. तो वी हैव टू सी व्हाट टू बी डन.
सर ये एक बार वापस दिखा दो सर. वो
वापस दिखाना
वही वाला है.
हो गया तो बोल दो. लॉगिन में डायग्राम मत बनाओ, कॉम्प्लिकेटेड है. Let me know when you're finished. Done?
Yes, sir.
Okay. Now let us see another regarding the moon. ये हो गया. अभी बाकी है daily retardation of the moon. Daily retardation. The moon rises, sets, and culminates on the meridian approximately 50 minutes later each day. This is known as, after one rotation, the observer is now rotating and also moving now, obviously. So Earth is moving and observer is rotating. एक मिनट, ये दोनों नहीं चाहिए. Okay. After a 360-degree rotation, when the observer again comes to the same point, the moon is not there. One minute. Let me just remove all this. We have to have actually another figure. The figure is Earth is like this. On the meridian, the moon is here. Yeah, so एक ही figure में हो जाएगा. After one, ये meridian है. ये observers का meridian है. After one rotation, when the observer comes back, say this is O. We call it O. When observer comes back to the same meridian, the moon is not there because the moon has moved by this much. Moon has moved in his orbit because moon is by this much. So from M1, moon has come to M2. So for that, now for the moon to come on the observer meridian, observer must come here. That means the moon is coming later on the meridian. Why? Because the moon is moving in its orbit. Understood is what I'm trying to say. The moon is moving here. Therefore, after 360-degree rotation, when the observer is back on the same meridian, moon is not there anymore. Moon is going to M2. For that, it has to go further to this much. So that is equal to the angle of moons in one day. So we can say that if you take 29.5, that is the moon is doing 360 degree in 29.5. So how many degrees it will go? So if we say 29.360 divided by 29.5, approximately 12.2, and 12.2 degrees, 24 divided by 360 into 12.2 into 60, 48.8, correct. So now I'll give you the calculation. So when let us assume, referring to the figure, obviously, referring to the figure, let us assume that the observer at O has the moon M1 on his meridian. After one rotation, when the observer comes back to O, the moon has moved in its orbit, to M2 and is thus not on the observer's meridian anymore. For this, the Earth has to rotate some more so that the observer is at, इसको तुम ये करो, इसको ऐसा मत करो, observer comes to, वो भी O2 ही कर दो, इसको O1 कर दो, पहले इसको मिटा दो फर्स्ट ऑफ ऑल, ये डायग्राम में थोड़ा चेंजेस लगाओ, ये O1 करो, that is initial position, and this is O2. इधर भी, after when he comes to O1, the moon has moved in its orbit to M2. For this, Earth has to move, to rotate some more, so that the observer comes to O2, and then the moon is once again on his meridian. The amount of rotation of the Earth for this is theta. So let us draw theta over here. ये theta है. This is theta. Theta. Which is equal to, what is theta equal to? Theta, which is equal to the angular motion of the moon in one day. ठीक है ना? अब इसको थीटा कर. Now we will give some, because अगर ये बड़ा क्वेश्चन तो you have to write the derivation also. The angular motion of the moon as per the what I told you, there are two types of period. One is the sidereal period and the other is the, who can tell me?
Solar period.
Solar period. Anybody? लोग सो रहे थे क्या क्लास में, लास्ट क्लास में मून के बारे में जब बोला? When I explain, no, sidereal period, explain sidereal period. बोलो. Sidereal month and what other month? Lunar month, no?
Lunar month.
Of the moon as per the lunation is 29.5 days. That is 12.2 degrees per day. How you get 360 divided by 29.5? Thus, the Earth has to rotate by 12.2 degrees, 2 degrees more, to have the moon once again on the meridian. The Earth rotates 360 degrees in 24 hours. Thus, this you can calculate and see, 12.2 degrees will take 48.8 minutes. That is approximately 50 minutes. That is what it is. This is called the daily retardation of the moon. This is known as the daily retardation of the moon, due to which it rises, sets, and culminates comes on the meridian. Culminates on the meridian approximately 50 minutes later each day. That is what it is. This is called as daily retardation of the moon. And this is why you have something called the longitude correction, which I will tell you. If you can confirm that अभी तक जो हुआ तुम लोग समझ में आ गया, then I will move forward. If you have any doubt, then I will explain. If not, we can continue with
एक
our.
मिनट रुक जाओ.
हाँ, रुक देता हूँ. Let me know when to start again.
तो सर इसका मतलब कि अगले दिन अगर आज 50 मिनट्स बाद में हुआ है तो कल 100 मिनट्स हो गया.
हाँ, more and more, correct. Every day it is 50 minutes later. आज अगर suppose moon comes on the meridian at 10 o'clock in the night, tomorrow it will come at 10:50, day after tomorrow it will come at 11:40, the next day will come at 12:20, like that 12:30, like that it will keep going backward and backward.
Okay.
Done?
So this means moon rising and moon setting
sir.
will be 50 minutes late.
No, sir.
daily.
Culmination on the meridian also, coming on the meridian also, all 50 minutes later.
Okay.
Right. Now what I will show you, एक minute, let me just, now that this is done, let us show you the practical aspect of the moon before we will.
1 minute, sir, 1 minute.
हाँ, करो, I am there, very much waiting for you, don't worry.
सर ये क्या लिखा आपने? This is known as daily retardation of moon due to which?
Due to which it rises. Due to which it rises, sets and culminates on the meridian.
Sir.
हाँ बोलो.
सर ये phases of the moon में हमने लिखा था the moon makes a revolution of 360 degree in 27.33 days.
Correct.
तो सर ये lunar month 29.5 days.
Sidereal period, I told you, no, that the lunar month is I give you a diagram, no, that the lunar month is greater than the sidereal month, because by the time the moon also is moving, the earth is also moving in its axis, and that is 29.5 days plus minus 13 hours. बोला कि नहीं?
सर diagram नहीं दिया था.
क्या? Tell me what I told about sidereal period and lunar. I'll explain now if you want. अगर नहीं दिया तो एक बार क्या बोला, एक बार रीड करो अगर तुम्हारे पास नोट्स है.
सर lunar month का paragraph लिखवाया था, उसमें लिखा था is the interval between two consecutive new moons or two consecutive full moons and has a period of 29.5 days plus minus 30.
हाँ बस उतना ठीक है, उसका डायरेक्ट दे विल नॉट आस्क यू. अगर इफ यू वांट आई कैन डू, बट वो थोड़ा कॉम्प्लिकेटेड है, बट आई थिंक आई हैड गिवन, बट लगा देता हूँ. चलो आई थिंक आई हैड गिवन. व्हेन आई ड्रॉ द डायग्राम यू विल रियलाइज दैट ये दिया हुआ था. ये अगर सन इधर है और ये अर्थ इधर है और अर्थ E1 है and this is a distant star. So when after 360-degree revolution, the distant star will once again be on the horizon. ये जो star था, suppose let me make all this smaller. ये earth and all can't be so big. इसको सब छोटा कर देता हूँ. छोटा कर दिया. Suppose in line there is also a distant star. After 360 rotation of the earth, the distant star will be on the horizon once more. But for the full moon again to take place, when after a full revolution, the moon has to come to M2 again. The moon has to come back here. Therefore, the moon has to rotate by an angle theta. By an angle theta, which is equal to the alternate angle theta dash, which is equal to the moon's angular velocity or angular momentum in one sidereal period. This is known as, so that is why the diagram you take, thus the moon has to, thus in addition you can add, for lunation to be completed, the moon has to move further in its orbit, to M2. And you can add one more at M1. Are you sure I have not given it? When moon reaches M1, one sidereal period is over. So this is, if I say this is M, this is M1 and this is M2. So to come to M2, it has to go further. This is equal to the Earth's angular movement in one rotation of the moon. Thus, the lunar period takes approximately, you don't have to go for the calculation here, but zarurat nahi hai. Approximately 29.5 days with a variation of plus minus 13 hours as per Kepler's second law. So this is what it is. Any doubt in this, anybody further? Yes, हमें आ गया diagram. So Hamsood, you're okay?
Yes, sir.
हमें आ गया?
Yes, sir.
मनोरंजन साहू? सौरभ कुमार?
Yes, sir.
Yes, sir.
Okay. Then what we will do now? You have Vikas Kumar. You understood?
Yes, sir.
Okay. So ठीक है, अभी मेरे को भी अभी मीटिंग में जाना है. So tomorrow we will do the moon calculation. Moon we have finished the theory. Tomorrow we will do the calculations of the moon. Keep the almanac ready. Tomorrow we will start at 9 o'clock in the morning, and we will finish the azimuth of the moon, rising and setting, the rising setting time, azimuth, long background, intercept. सब कल हो जाएगा. So moon finish. Then next we can go to the other things. ठीक है?